Welcome to The Explainer. Today, we are diving into something really fascinating, the unsung hero of your boat. It's this small, pretty inexpensive part that, believe me, stands between you and potentially thousands of dollars in repairs. So let me just ask you this straight up. Why on earth would you want a part of your boat that's literally designed to be destroyed? I know, it sounds completely backward, right? But stick with me, because the answer is the key to protecting your boat from an enemy that's invisible and absolutely relentless. And this enemy, it is not cheap. According to the experts at NACE International, corrosion damage costs the U.S. economy a jaw-dropping $276 billion every single year. And you can bet the marine world takes a massive, massive hit from that. So yeah, the scale of the problem we're talking about today is just huge.
So here's our game plan, our mission for today. First up, we're going to identify that invisible enemy. Then we'll meet our hero and figure out exactly how it works its magic. After that, we'll cover the super critical step of installation, lay out a battle plan for inspection, and finally, learn how to choose the right hero for your specific situation.
All right, let's kick things off with the villain of our story. We're talking about an unseen force that is constantly and silently trying to eat your boat from the inside out.
So this enemy, it has a name, galvanic corrosion. And here's the simple version. Don't worry, we're not getting too sciencey. When you put different types of metal, say a bronze propeller and a stainless steel shaft, into salt water, you've accidentally created a battery. Seriously. And just like any battery, there's a flow of energy, and that process has to consume one of the metals.
And here's the problem. That natural battery you've created, it decides to eat your most expensive and most critical parts first. We're talking about your props, your shafts, your engine components, all the stuff you really, really don't want to have to replace. But this is where our hero finally enters the story. And it's such a simple, brilliant solution. It's called the sacrificial anode. So how does it work? Well, the anode is made of a metal that is way more active, or you could say more appealing to that corrosive battery, than any other metal on your boat. So when it's installed the right way, it bravely steps in and basically shouts, "Hey, eat me instead." The anode corrodes, it gets sacrificed, leaving all your expensive parts totally safe and sound. Now, let's clear something up. You might hear people around the marina call this electrolysis damage, but that's actually a common mistake. What's really happening is just this natural chemical process, galvanic corrosion, that's running wild because an anode is either missing, all used up, or, and this is a big one, installed wrong. The good news? It is entirely preventable. And that brings us to maybe the most crucial part of this whole thing. An anode is only a hero if you arm it for battle correctly. This is where so many boat owners get it completely wrong. I want you to think about this for a second. According to the Journal of Marine Engineering and Technology, a mind-blowing 60% of all protection failures, they're not because of bad anodes. Nope, they're because of poor electrical contact from a bad installation. 60%. So let's talk about the 3 unforgivable sins of installation. First, never, ever, ever paint an anode. Paint is an insulator, it makes the anode totally useless. Second, never mount it on a dirty or painted surface. You need clean, bare metal touching bare metal for it to work. And third, make sure those fasteners are tight. A loose anode is a useless anode. Simple as that. Okay, so your hero can't fight forever. A huge part of being a good boat owner is knowing when your anode has done its job and it's time to call in a fresh replacement. And the rule of thumb here is super simple. It's called the 50% rule. Once an anode is about half gone, its surface area gets so small that its ability to protect your boat just plummets. So don't wait for it to disappear completely. The second it hits that 50% wear mark, it's time for a new one. And how do you know when it's at 50%? You gotta look. You inspect it. And get this, a 5-year study by Boat US found that boat owners who did quarterly anode checks filed 72% fewer corrosion-related insurance claims. That is not a small number. That is a massive difference. And if you're wondering about the financial stakes, well, they are very real. This quote says it all. A potential $5,000 repair job was completely preventable with just $50 worth of anodes. I mean, that's probably the best return on investment you can possibly make for your boat. Okay, for our final section, there's a little bit of a twist. It turns out that not all heroes are created equal, and choosing the right material for your anode can dramatically change the level of protection your boat gets.
So when we actually compare the options, a clear winner emerges from most of us. Zinc, that's the old traditional standard, but it can get this crust on it and fail in fresh or brackish water. Then you have magnesium, which is super powerful, but really only for freshwater boats. And that leaves aluminum. It works great in all water types, and according to expert testing, it can last 30 to 40% longer than zinc.
Now, here is a really crucial point. Consistency is everything. Once you pick your hero material, you have to stick with it across the whole boat. If you start mixing anode types, like putting an aluminum one here and a zinc one over there, they can actually start to fight each other, and that can reduce your boat's overall protection by as much as 60%. And hey, you don't have to take my word for it. The U.S. Coast Guard themselves recommend aluminum anodes for most recreational boats. They call it the best balance of protection, longevity, and environmental impact. It's really the modern standard for a reason. So let's wrap this all up with your final mission briefing. First, identify all your anode locations, and don't forget about those little internal pencil anodes inside your engine. Prepare the mounting surface perfectly before you install a new one. Inspect them regularly, at least quarterly, and replace them at 50% wear. Choose the right material for your water type, which for most people is going to be aluminum. And finally, keep a little log so you can track how fast they're being used up. Which really leaves us with just one final question to think about the next time you're heading out on the water. Is your boat's silent hero properly armed, inspected, and ready for duty? I promise you, your wallet will thank you for making sure that the answer is always yes.